Lesson 17.3, we're finishing task 2. All right, it says consider the expression 2x squared minus 9x plus 10. If you want to factor the expression where m and n are positive, what must be true about the signs of p and q? All right, select the phrase to complete the statement. So p times q has to equal 10, and it has to add up to be negative 9. So in order to multiply and get a positive, I need 2 positive or 2 negative. The fact that this is negative in the middle means I need 2 negative signs to get the correct answer when I factor. All right, so let's continue. It says complete the factored form. All right, so we've got 2x squared minus 9x plus 10. All right, so before they showed you how to make the table, and the table is great. It's a little time consuming, but it's helpful if you are not good with multiplication and you're using maybe a calculator the whole time to kind of get those factors. That may be helpful to create that table, but I'm going to show you how to create kind of a smaller table and go through the steps. You're always going to get the right answer, but it's a little bit, in my opinion, a little bit faster. So we're going to multiply a times c. So we're going to do a times c, and then we need to add to get b. All right, so I need a times c. Remember, this is ax squared plus bx plus c. So this is my a, my b, and my c. So when I say I need to multiply a and c and add to get b. So that's my requirement to get my factors here. So let's go ahead and start off. A times c, 2 times 10. So 2 times 10 has to equal 20. And add to get b, so I need to add to get negative 9. All right, so I'm going to look for all my factors of 20. So I'm going to have 1 times 20, 2 and 10. 3 doesn't go into 20, 4 and 5. Now we've already determined from the last question that these all have to be negative. Because when I multiply, 2 negatives give me a positive, and when I add 2 negatives give me a negative. So I can see right here, to multiply to get positive 20 and to add to get negative 9, I get these 2 numbers here. Now, that's not just my factors. That's not what I'm going to plug in here, okay? So I'm going to bring down my 2x squared, and what I'm going to do is rewrite this middle term. Negative 9x is the same as negative 4x and negative 5x. So I'm going to do negative 4x minus 5x, which negative 9 is the same as this. I'm just rewriting that, plus 10. So now I can group these. So I'm going to group these and pull out my greatest common factor of each. So in the first binomial, what is my greatest common factor? That would be 2x. And if I pull a 2x out of my first term, I'm left with x. And 2x from negative 4x is negative 2. And again, you can check that quickly. 2x times x is 2x squared. 2x times negative 2 is negative 4x. All right, move on to the second binomial. We're going to do the same thing. What do these have in common? My greatest common factor is negative 5. And if I pull a negative 5 out of the first term, I'm left with x. And if I pull a negative 5 out of positive 10, that's negative 2. Check it. Negative 5 times x, negative 5x. Negative 5 times negative 2 is 10. So all I've done, again, is rewrite this here. Now I can see that these have a common factor. X minus 2 is my greatest common factor. Pull it out, and then I'm left with 2x minus 5. So my two factors are x minus 2 and 2x minus 5. Now if you prefer the table, by all means make the table, but I just like this method better. I'm going to check it. X times 2x is 2x squared. X times minus 5 is negative 5x, plus negative 4x is my negative 9x. Negative 2 times negative 5 is positive 10. So these are correct. So now I can say 2x minus 5 and x minus 2. And because multiplication is works with associative and commutative property, the order of the factors do not matter. Now it does matter which number goes in which factor, but it doesn't matter the order of the factors. So what I'm saying is, let me try to write this down here. Alright, so I can write it as 2x minus 5 and x minus 2. Both of these are correct. But if I change the number, if I try to write x minus 5 and 2x minus 2, that is not correct. See, if you multiply, you get 2x squared. Minus 2x minus 10x is minus 12x, which does not work in the middle. So this would not work. All right. All right, if you want to write that down, please do so. We're going to move on to the next example. All right, it says sometimes the terms of an expression have a common factor that should be factored first before completing the factorization. So what is the greatest common factor here? All right, so I'm going to have 18x squared plus 39x plus 6. Now, again, factoring is really helpful if you know, or if knowing your multiplication tables is really helpful for factoring. That's what I'm trying to say. So I can look here and I can say 3 goes into each of these terms evenly. 6 goes into the first and last term evenly, but not the 39. So we know it can't be this one, okay? So we know already it's got to be a greatest common factor of 3. So if I pull out a 3 times what gives me 18x squared. So that's going to be 6x squared. 3 times 13x and 3 times 2. So we know our greatest common factor is 3. And now I'm going to factor this expression again. So I'm going to have, I'm just going to go ahead and bring 3 down here. 3 is part of my answer. Now I'm just going to look at this part. All right, so I'm going to do what I did in the last example. I'm going to do A times C. A times C. 6 times 2 is 12. And I need to add to get B. All right, if I add to get B, I need to add to get 13. All right, so what are my factors of 12? So I've got 1 and 12, I've got 2 and 6, and I've got 3 and 4. All of those multiply to give me 12. What also adds to give me 13? Well, this gives me 8, this gives me 7, 1 and 12 are the only ones that give me 13. Because these signs are both positive, I know this is positive 1 and positive 12. Again, all I'm going to do first is rewrite my middle term. So I've got 6x squared plus, and I can write these in any order I want, but I know 6 and 12 are easy to go together, so I'm going to put 12x plus 1x plus 2. Now, anytime I have 4 terms, I can group 2 of these together at a time. I can look at 2 binomials and then look at the greatest common factor. So here I've got 6x squared plus 12x. My greatest common factor is 6x. And then I have x plus 2. So 6x times x is 6x squared. 6x times 2 is 12x. So again, this is just rewriting this in factored form. Here I can factor out a 1. Nothing else will come out of here. I'm left with x plus 2. And now I have a greatest common factor. So x plus 2 is my greatest common factor, and I'm left with x plus, or 6x plus 1. Now, the reason I need that plus 1, because this is supposed to be a binomial. If you don't have that, you don't have that placeholder. So now we have 3 times x plus 2 times 6x plus 1. So now we have to look at this and see which one of those would be the correct term. So it's going to be the first one. And that is all for task 2. If you have any questions, please let me know. All right, lesson 17.3 on factoring. I'm going to do a couple more examples before we go on to the next task. So let's look at number 10 here. So it says 6x squared plus 13x plus 6. And I want to factor this expression. So how I've showed you was you want to get a times c, a, b, and c. So a times c is 36. And I want to add to get b. So I need to add to get b. If I add to get b, I need a positive 13. All right, so I'm going to look at my factors of 36. So that's 1 times 36, 2 times 18, 3 and 12, 4 and 9, and 5 doesn't go into it, but 6 and 6 does. All right, so all of these multiply to give me 36. Now we know that both signs are positive, so we need a positive 13 as well. So I look down through here, and 4 and 9 add up to give me 13, and they multiply to give me 36. So that's going to be my new middle terms. So 6x squared. Now I need plus 4x plus 9x. Again, 4x and 9x is just in place of the 13x. And the reason I do this, now I have 4 terms. When I have 4 terms, I can group them as 2 binomials. All right, my greatest common factor here is going to be 2x. When I factor a 2x out of 6x squared, I'm left with 3x. 2x times 2 gives me 4x. And then I do the same thing with the second binomial. 9x and 6 have a greatest common factor of 3. 3 goes into 9x 3x times. 3 goes into 6 2 times. All right, so if you notice, I've done a couple of these examples now. The greatest common factor should always match here. 3x plus 2 if you're doing this correctly. And then we're left with 2x plus 3. All right, and then these are easy to check using distributive property. 3x times 2x, 6x squared. 3x times 3, 9x plus 4x. 9 and 4 give me 13x out of the 2 middle terms. And 2 times 3 give me 6. So I can very quickly check that and make sure that I got it correct. All right, I think we've got time for, one more example. Let's see if I can erase this real quick, and we will look at one more. You can always pause these if you want to take notes, write things down. So just make sure that you are doing that. All right, let's look at number 12 since it has a negative sign. So we've got 2x squared plus x minus 10. First thing I'm going to do is a times c. A times c is negative 20. And then I need to add to get b. Add to get b is positive 1. Okay, so when I multiply a times c to get a negative number, that means I'm going to have 1 positive and 1 negative. So I'm going to have opposite signs this time. So I'm going to have 1 and 20, 2 and 10, 3 doesn't go into it, 4 and 5, and I'm going to have opposite signs. And the way I know is that b has to be positive 1, so 5 has to be positive, and 4 has to be negative. Negative 4 times 5 equals negative 20. Negative 4 plus 5 is positive 1. So once I have my middle terms, 2x squared in place of x, I'm going to put negative 4x plus 5x minus 10. All right, I'm going to pause this and finish it so that you can see the final answer at the end before the video shuts off. All right, so I did factor out the greatest common factor here, and I factored out the greatest common factor here, and then that leaves me with this expression and checking it